Welcome to Suhail's Paramedical and Nursing Academy. Today I am going to explain about the renin angiotensinogen renin. Today I am going to explain about renin angiotensinogen aldosterone cycle. So today's topic is renin angiotensinogen aldosterone cycle. That is also called as RAAS. So RAAS means renin angiotensinogen aldosterone cycle. Renin angiotensinogen aldosterone cycle. Okay, so in renin angiotensinogen aldosterone cycle, what I am going to explain. See, so renin angiotensinogen cycle, what is actually RAAS, renin angiotensinogen aldosterone cycle? So actually it is a mechanism in the body. It is a mechanism that happens in the human body. Why this mechanism happens? Actually RAAS system is what? Actually this RAAS system increases the BP in our body. Whenever there occurs hypo, because see, BP, blood pressure increases in our body by means of two ways. One is by means of long time system. Another is short time system. Short time system means within very less time. That is another. I am not going to explain that. Here it is a long time. This RAAS system takes 1 to 2 hours. It takes 1 to 2 hours to increase the BP, to increase the blood pressure again. So suppose what happens, whenever in our body there is decrease in the blood pressure, whenever in our body there is hypovolemia, whenever in our body there is decrease in blood pressure, decrease in blood volume, decrease in what? Blood volume, or there is any shock, hypovolemic shock, or any kind of hemorrhagic injury, hemorrhagic stroke, we can say hemorrhagic shock. Hemorrhagic shock means there is excessive loss of blood. Whenever these conditions happen, whenever there is decrease, or suppose in case of burns, if in case of burn also there is very high loss of fluid in the body. So what body will do? Whenever there is loss of fluid in the body will try to, because loss of fluid is there, but blood pressure should not decrease less than normal. So it should remain under the range. So what body does? How to maintain the blood pressure? Body uses a long time mechanism that takes 1 to 2 hours. That is called as RAAS system. RAAS system is actually a hormone system where hormones are acting there, where enzymes are acting there. Okay, so what happens? I will tell the mechanism of RAAS, how the RAAS system acts. So I told it takes 1 to 2 hours. So what happens in the body? Whenever there is shock, or there is hypovolemia. Whenever there is shock, whenever there is hypovolemia, or whenever there is any burn, or any kind of hemorrhagic shock. So what happens in these cases? Shock, hypovolemia, burn, hemorrhagic shock, there will be decrease in BP. There will be blood pressure. The blood pressure will be decreased. So whenever blood pressure will be decreased, what happens? There is in our body, there is a special excretory organ. That organ is called as kidney. So what will happen? That kidney has a mechanism. Kidney possesses receptors. Kidney has receptors. Inside the kidney there are receptors who can identify, who can know that there is decrease in the pressure in the blood. We can say they are very sensitive to the blood pressure. They are very sensitive to the electrolyte balance. If there is decrease in the sodium level, definitely in kidney will get stimulated. What happens in the kidney? In the kidney, see blood pressure. I told you blood pressure decreases. Kidney kidney will get sensitized. What happens? The kidney, this is the kidney, okay? The kidney will release renin. This renin is R-E-N-I-N. R-E-N-I-N. Renin is a hormone that is secreted by the kidney. In kidney, where it is secreted? From the juxtaglomerular cells, JG cells. There is a apparatus within the kidney that is called as juxtaglomerular apparatus. From the juxtaglomerular apparatus, this renin hormone will be secreted. What does do? Renin actually already in the blood. What I will tell what renin is doing. Already in the blood, there will be availability of angiotensinogen. What will be there? There will be presence of angiotensinogen. So already in the blood there is angiotensinogen. This angiotensinogen will be converted into angiotensin first. This angiotensinogen will be converted into angiotensin first. This angiotensin that was already present in the blood, already in blood. Actually, where it comes from, how it comes from blood? It comes from liver. It comes from liver. So already what happens? Angiotensinogen is present in the blood. That is already secreted by the liver. It is present in the blood. This angiotensinogen needs to convert into angiotensin first. Here, kidney secretes renin. Renin converts angiotensin into angiotensin first. Remember this much. Then renin, angiotensin first. Then from lungs. This angiotensin, because these all hormones are running in the blood. This blood, when this angiotensin first will reach to the lungs, inside the lungs they produce angiotensin converting enzyme, ACE. Angiotensin converting enzyme. What happens? This angiotensinogen is converted. Angiotensin first is converted into angiotensin second now. Angiotensin first is converted into angiotensin second. Remember this angiotensin first is converted into angiotensin second by the angiotensin converting enzyme that has been secreted by the lungs. So lungs secrete angiotensin converting enzyme. That angiotensin converting enzyme converts angiotensin first into the angiotensin second. Remember, this angiotensin second is an active form. Now it can do the work. Angiotensinogen was initially already in the blood, that is secreted by the liver. That was not functional. Now it is in the functional form. That is angiotensin second. Angiotensin second. Angiotensin second, what it will do? It will do three things. Remember, angiotensin second is a vasodilator. It is a vasodilator. Angiotensin second is a vasodilator. It will increase the diameter of the blood vessels. Whenever there is increase in the diameter of blood vessels, the blood pressure will be decreased. The blood pressure will be sorry. What I am saying is that angiotensin second, when angiotensin second it is present in the blood, angiotensin second is an active form. What I am actually want to say is this: we have to increase BP. There is already decrease in the BP. We have to increase in the BP. BP will only increase when there is vasoconstriction. So it will do vasoconstriction. Sorry for the first word. I told vasodilator. No, it is a vasoconstrictor. So first work is vasoconstriction. Second work. So when it will do vasoconstriction, there will be increase in BP. Second thing, it will go to the adrenal gland. From adrenal gland, because adrenal gland, we all know adrenal gland is suprarenal gland. It is above the kidney. And from the adrenal gland, this angiotensin second stimulates what? Adrenal cortex. From the adrenal cortex, there are three parts. I will not go in that detail. I will say from the adrenal cortex that angiotensin second stimulates adrenal cortex. From there, the aldosterone will be produced. What will be secreted? Aldosterone. So the aldosterone is produced from the adrenal gland. What it will do now? Aldosterone what aldosterone will do, I will tell that also. So first it is a vasoconstrictor. What? Angiotensin second. This angiotensin second will also stimulate production of aldosterone from the adrenal gland. Then another thing, it will also stimulate pituitary gland. It will also stimulate pituitary gland, and it will secrete what? Antidiuretic hormone. From pituitary gland, it will stimulate pituitary gland also. Inside the pituitary gland, there is a posterior pituitary pod. From the posterior pituitary pod, antidiuretic hormone is already stored. It will stimulate the release of antidiuretic hormone. That antidiuretic hormone is what? It will increase the water reabsorption within the kidney. It will increase the water reabsorption within the kidney, so volume of blood will be increased, so blood pressure will increase. That is antidiuretic hormone. Another I told, adrenal gland. Adrenal gland will do what? From adrenal gland, I told you there is secretion of aldosterone. Aldosterone is another, is also hormone. It will also stimulate sodium water reabsorption, but potassium excretion. So there will be sodium reabsorption. There will be Na positive reabsorption, sodium reabsorption, and there will be